Drying and cleaning compressed air for use in manufacturing, fabrication, and research applications is critical to the success of the operation. Let's briefly examine the problems that can be caused by compressed air. The air discharged from a compressor is usually hot. Cooling it causes condensate, which can contain particulate material, oil, and other contaminants. Corrosion in pipelines can add to the particulates. Additionally, acids, oils, and mists are all transported by compressed air. Air cooled at the discharge point may mar surface finishes in painting operations, blasting media operations, and other operations such as cylinders, valves, instruments, actuators, and air tools. Many of these problems can be prevented by depressing the dew point of the compressed air. There are 3 techniques to accomplish this. Refrigeration drying, which condenses liquid by cooling. Pressure dew points are limited to 35 degrees Fahrenheit to prevent freeze-up. Filenco dryer filters are often used to produce dew points below freezing where required, downstream of the refrigeration dryer. Deliquescent drying, which uses water-absorbing inorganic tablets to remove moisture. And desiccant drying, which absorbs moisture with porous materials. What about filtration? Conventional 5 to 40 micron filter units help to filter and remove condensate from air that is already cool, but they don't depress the dew point. More condensation may occur downstream as air cools further. These commodity filters generally do the job for which they've been designed, but in today's sophisticated environment, many applications require greater efficiencies. These conventional filters are just not efficient enough for many of today's tool and instrument applications. Filenco dryer filter units combine desiccant drying with final filtration and separation, raising the level of performance significantly over conventional commodity filters. Our patented dryer filter provides triple action cleaning, separation, drying, and filtration, all in a single unit. Through creative application of absorption filters, we can include a 4th action, oil mist removal. These multiple functions in a single unit reduce installation and replacement costs to restore like-new operation and tailor the degree of performance to your specific requirements. Let's look at Filenco's patented air cleaning system. Air enters the lower section on a tangent and is centrifuged around an inverted cone. This action flings condensate and particulate material to the wall, where they drop into a discharge drain. This drain can be manual, automatic float, or electronically timed to discharge. Air then passes through openings in the cone and contacts desiccant contained in a synthetic fiber bag. Our small units use a special polyester bag. The bag on the larger sizes is polypropylene for additional strength. The bag is supported by a stainless steel screen. Coarse filtration takes place near the bottom of the bag, and drying occurs throughout the desiccant to decrease the pressure dew point. Fine particles, some desiccant and some particulates in the original airflow, are trapped by a set of filter discs. The air is filtered to a nominal 1 micron level. The filter discs are firmly secured to the top cover spacer on smaller units or to a separate spacer on our larger models. Oil aerosols can be trapped by activated carbon in the desiccant bag or by absorption pads in the filter discs on optional constructions. The form-fitted desiccant bag fits into a cast aluminum housing, which is finished with a polyurethane powder coating inside and out. This results in a smooth interior, allowing for easy assembly and installation on the bag. Filter discs attached to the cover fit snugly on the smooth interior sidewalls and seal the unit for final filtration. A V-clamp, equipped with disengagement knobs, effectively seals the unit's top cover. When it's necessary to replace filter elements, Filenco offers a 5-part filter fix-it kit, which includes a new bag of desiccant, 2 sets of filter discs. The first, for units made before 1993, are solid and sandwiched between 2 stainless steel screens. The second fits units manufactured after 1993. They have holes in the center, so the lower screen can be screwed to a threaded stud. This firmly secures the filter discs to the cover and spacer, or spacer alone. A new O-ring or square ring to seal the cover to the housing. a complete set of instructions, and a yellow label used to record the date of latest filter change. This test model illustrates how effective even the smallest unit in the line can be. Used mainly in OEM applications, it is rated for 7 SCFM at 100 psig. Moisture is introduced into the air by a lubricator at a rate of 1 drop per second. The condensed water flows into the separation section and drops into a piston-activated drain, specifically designed for this small unit. Pressure swings caused by interrupted airflow from an intermittent operating solenoid activate the piston drain to discharge condensed liquid. Air then passes through the desiccant bag where it is filtered and dried, then through the final filter, where laser tests have shown that more than 99.9% of particles 1 micron or above are removed. In this test model, the air is then discharged into an inverted polycarbonate bowl. As you can see, there is no condensate here, even after the air has expanded and cooled. To meet specific application needs, Filenco dryer filters are available with 3 standard desiccant combinations: clay, molecular sieve, and clay with carbon. Clay, the most commonly used desiccant, absorbs water and oil. Dew point depression is approximately 20 to 25 degrees Fahrenheit below incoming air temperature. This desiccant requires no other advanced air filtration and is suitable for individual pieces of equipment, spray booths, blast cabinets, or even small departments within large facilities. Molecular sieve, used in the pellet form, will suppress dew point by 60 to 80 degrees Fahrenheit. A coalescer must be used to remove oil from the air because the molecules in compressor lubricating oil are larger than the pore size of the molecular sieve. Without a coalescer, oil droplets will collect on the surface of the molecular sieve, blocking water absorption. This is also common to activated alumina, frequently used in twin tower regenerative dryers. The coalescer in Filenco dryer filters and twin tower regenerative dryers is critical for long life of the desiccant. The clay and carbon desiccant combination is oriented in 2 layers. Clay, on the lower layer, absorbs moisture. On the upper layer, activated carbon removes fine oil aerosols and solvents. The 2 layers are separated by a filter disc to prevent sifting. This desiccant is used in applications when oil-free air is required, such as in laser equipment, where air cylinders are used to position the laser. Oil aerosol discharged from these cylinders can coat the mirrors that direct the laser, requiring expensive cleaning and readjustment of the entire system. When changing the filter elements, all pertinent safety precautions regarding pneumatic equipment must be followed. Filenco has designed our equipment to permit desiccant change by any competent shop person. No tools are needed. First, the dryer filter should be isolated by shut-off valves upstream or downstream, or by shutting down and locking out the compressor on smaller systems, so the unit will not be opened under pressure. Residual pressure in the unit is bled through the discharge drain. Once pressure has been relieved, the knob securing the V-clamp is unscrewed, the clamp and cover removed, and the desiccant bag pulled out by the convenient strap. The lower stainless steel screen is unscrewed so that the old disc set can be removed and a new one installed. The change is completed by snugly reinstalling the lower screen and bag. Then the cover is reinserted and the V-clamp secured. Pressure is restored, first opening the upstream valve and then slowly opening the downstream valve. Filenco's filter dryer line includes packaged systems for parallel flow operation to increase capacity or to provide operation redundancy. These duplex units are designed for departments in large factories or individual sophisticated machines. With the addition of a moisture indicator, the operator can easily see when the desiccant needs to be changed. Changeover is quick and easy. The operator shuts off the saturated desiccant unit and turns on the unit with fresh desiccant. Within a few minutes, the moisture indicator returns to its blue color, indicating dry air is flowing. Change out of the saturated desiccant can be accomplished on a routine maintenance call, eliminating a costly shutdown.